Hello everybody, how are you doing? Today we'll work with extreme order functions and we consider some examples. We use the necessary condition as sufficient condition to define the maximum or minimum of the functions. I remind you that we have two conditions. The first one, f of x has extrema at points x if first derivative is 0. I do not like curve brackets, parentheses and curve brackets. And it is necessary condition and sufficient condition if f double prime of x, the second derivative, is positive, it is minimum, and if it is negative, it is maximum. It is sufficient condition. So we have necessary condition and sufficient condition of the extremum of the function. So we have necessary condition of the extremum, and we can define if it is minimum or maximum if we calculate the second derivative of the function x. I think it's not very clear because with no example. And now we have some examples. I want to start from the easiest one. Example. So I have function y equal x squared minus x, and I want to know the extrema of this function and define either maximum or minimum. So I have to calculate the first one step here. I have to calculate first derivative of the function. X squared gives 2x, x gives 1. Second step, I have to know x is when this expression turns into 0. 2x minus 1 equals 0. So x equal 1 over 2. It means that at this point x squared minus x has extremum. At x equal 1 over 2, x squared minus x has an extremum. I still don't know if it is maximum or minimum. So to define it, I'll have to use the sufficient condition and calculate the second derivative of the function. The second derivative over x gives me, I have to take this formula and calculate derivative of it. 2x gives me 2 and minus 1 0, so it is always 2. It means that it is always positive. So it is positive, it means that what? It means that x equal 1 over 2 is a minimum of the f of x. The value of the function at this given point is what? Y equal 1 over 2 squared minus 1 over 2, and I have minus 1 over 4. 4. It is 4, not y. Minus 1 over 4. I don't know. It doesn't matter what is it. We know that it is a minimum of the function. Okay. Next example. Example 2. We have a given function x cubed minus, for example, for example 75 x. Okay. So I want to calculate, define x's, then it has maximums or minimums. So Extrema. So the first one step, I have to calculate the first derivative of y. So y prime or x cubed minus 75 for fixed derivative, so it gives me 3x squared minus 75. The second one step, I have to calculate, I have defined x's, then this expression turns into 0. If I cancel 3, I have x squared minus 25 equals 0. Since that x squared equal 25, and I have x1 equal 5, x2 equal minus 5. So here I have two extreme. Two extreme I have here, but I still don't know if they are minimum or maximum. And the third one step, I have to use the sufficient condition and calculate the second derivative of the x. I have to take this formula, calculate derivative, it gives me 6x, and 6x equals 0, x equals 0. I'm sorry. 6. And now I have to check if it is positive or negative at the given 0.5 and minus 5. So if I put 5 here, the second derivative f of x gives me 6 times 5, it is 30. So it is positive. So when x equals 5, it is minimum. When I put minus 5, minus 30, it is negative. So it means that x equals minus 5, we have maximum of the functions. So one more again. To define the extrema of the function, I have to calculate the first derivative, make equality to the 0, define x's, then we have this left part equals 0, I define here. So calculate the roots of the equation, I define two of them. And if I want to know are they maximum or minimum, I have to calculate second derivative and check the sign of the second derivative at two given points. It shows for x equal 5 positive, it is always positive, so it is minimum, and for minus 5 it is negative, so it is maximum point. See you later. Bye bye. It's enough for today.